So looking at what we've covered recently, passed the midterm exam array lists. We also talked about stacks and queues at that time. Then we went to aggregation, composition, and inheritance. Keyed in on inheritance, but you know what aggregation and composition are. Those are putting classes inside of classes. You make a company, you know, a car dealership, and then inside that you have references to cars and references to employees. And whether it's aggregation or composition depends upon whether you are including things that could be shared between more than one object. You know, can an employee work at more than one company? Yeah, probably so. Then we've talked about polymorphism and interfaces, which is the natural sequel to inheritance. And we're going to hit exception handling right now, and after that we're going to do file handling. Writing files, reading from files. A couple of different ways to do that. It's going to look different than how we did it in C++ or Python. So this is probably going to be some new material for you conceptually, the file handling. You have to cover exception handling before you cover file handling, because files can generate all sorts of exceptions. And what is an exception? You've seen them. When you run it, you get an error, and it stops your program. I'm just creating a little dummy file that all I'm going to do is to say int x is equal to 1 divided by 0. That's an exception. So it doesn't matter if you type this in, but eventually I'm going to have you add some exception handling of your own. So x is equal to 1 divided by 0. We run it, and boom, we get a whole bunch of red text. Exception. What is the exception? Java.lang.arithmetic exception. That is the exception that was caught. There are more than one kind of exception. What if you try to parse something? You know, int x is equal to integer dot parse int, and you give it something that's not an integer, like whatever. I'm going to comment this one out. We've already seen that exception come up, but I'm going to put a little text here about what the exception was. Java.lang arithmetic exception. Now I'm going to run it again. This is going to be another error, right? Because you cannot change that string into an int. Alright, so we've seen two different kinds. This one also choked with a whole bunch of red text. It's a java.lang.number format exception. Now remember, java.lang is imported into every program, every file we write. So we could just call it an arithmetic exception rather than include all that. And this one could just be called a number format exception. I'm going to comment that line out because it also gives us an error. Alrighty, let's go read in the PowerPoint a little bit about exception handling. The idea is that you surround this code with something that puts kind of a buffer, a wall, around the dangerous code. This is the dangerous code. We're doing integer division. It's possible to divide by 0, so we would want to put a little wall around it. And then if a problem occurs, we need another little chunk of code that's going to handle that problem. So keep that in mind. We're going to mark off our dangerous code in one block, and then we're going to add a block that handles a problem if there is one. Oops. So, some API method calls are dangerous in that they might lead to a runtime error. What is a runtime error? A runtime error isn't a syntax error. It's not a logic error. It's just when the program hits a state from which it cannot recover by itself. And you've all seen runtime errors if you're Windows users and you're running a program and suddenly it says Windows has detected an error, now shutting down your program. You know, great. I lost my program. You know, whatever. So a runtime error is something like it cannot open a file because the file name does not exist, or the file name is, you know, bad for whatever reason. On a Mac, if you put colons in a file name, it gives you an error because you can't have colons in a file name on a Mac. It's the that's how you distinguish between directories, just like slashes are used on Windows. A lot of API method calls are safe, meaning no runtime error possible. Once you correct any syntax errors in them, it's going to run, and it's going to run correctly every time. Now, it may not give you the output that you want, but it's not going to blow your program up. But there are other things that are riskier. ParseInt, for example, might get some bad data. And if it does, it crashes with an exception. It doesn't necessarily crash, but it, quote, generates an exception, or it throws an exception. Those are kind of synonymous terms, and we'll see how to use the throws keyword later. But since this can blow up, we need a technique for handling runtime errors. That's known as exception handling. You surround the method call with a try block, and you insert a catch block immediately after the try block. So I'm going to go back to my code and do that. And if you want to type along, that's cool. Let's do that. Let's modify this code so that each one of these things actually has a chance of working. I'm just going to write it again, though. String s is equal to bad data, right? Int I is equal to 0. Int answer, the result, is equal to, we don't even need that, but I'm going to also initialize it to 0. Now let's write some code. We're going to ask the user for a value, and then we're going to try to parse it into an int, and then we're going to try to use it in division. And so we have two potential runtime errors coming up. Now we're going to need a scanner. Forget it, I'm going to leave the package statement. Import lowercase java, lowercase.util, uppercase scanner. Go back down here, let's make a scanner above our variables. Why not? Scanner sc is equal to new scanner system.in. Let's tell them that we want an integer. System.out.println. Please enter an integer, or a whole number. Now we're not going to warn them that that number, if they type in a 0, could crash the program. We ought to, but we're not going to for the purposes of this. And even if we did, they might type it in anyways, just to be rebellious. So here's the first line we're going to do is we're going to use integer.parseInt to convert it. I is equal to, wait, we haven't even read it in. S is equal to sc dot next. That's good enough. Why am I not using nextInt? Because I'm trying to illustrate a problem and a solution for it. So instead we're reading it as a string, and then we're going to convert it ourselves. So I is equal to integer, capital I, dot parse, lowercase p, int, uppercase I, s. Now let's divide the value 1 by that. This is a really dumb problem. How about 10? Or even 100? 100 divided by I. So we see two problems. That one can blow up. That one could generate an exception. And then let's write out our answer. System.out.printf 100 divided by %d is \n. No, wait, not is. And then 100 divided by %d is %d \n, end quote, comma. Now we need to print out our variables themselves. I is what we're dividing by, and R is our result. Close parentheses, semicolon. Now let's run it and make it work. That's what programmers usually do, is they write some code and then they test it to see if it works. They usually don't write it to see how they can make it fail. That comes with experience. Please enter a whole number, 10. 100 divided by 10 is 10. Okay, so my code works. Pause here for a moment. So if you don't have that working, if it doesn't run for you, pause the video and get it running. Here's our code. We import the scanner. We declare some variables. We print a message. We get a string in with sc.next. We convert it to an int. We do some division. Now these are the two trouble spots. I'm going to run them again and I'm going to make it crash. So here we go. Please enter a whole number. 10.1. Exception. All right, that blew up. I've learned my lesson. Don't enter a partial number. Okay, now I'm going to run it again. Enter a whole number. I'm going to go ahead and enter a whole number. 0 is a whole number, and we get another exception.
Is there a way that you can increase the font for the whole application and not just the editor?
No.
No.
Yeah. The question is, can you increase the font for the entire editor? And I'm not aware of a way to do that. You can increase the size of your output window by holding the control key down and spinning your mouse. I wish you could do that here. For some reason they didn't do that here, but they did it on the output window. Okay, so we have two places that can crash. So you can try to do it kind of on an atomic level and capture each thing that could crash, or you can cordon off the whole block and say it was risky. I think I'm going to approach it that way. But then we may go back and we make it more atomic to where they have to enter a good integer, where we loop until they give us a 1. Okay, so what we need to do is to cordon off our dangerous code, our exception generating code, in a try block. And is a printf dangerous? No, it's not, but it does depend on this stuff working correctly, right? There's other ways I can handle that, but if these two things don't work, then that's not going to work. So if I put that after the try block, then it's possible you could get there without valid data. So I think for now I'm just going to leave that printf there. So that is going to have to succeed, and that is going to have to succeed before that works. And if neither one of those work, then it's not going to run that, because an exception, if it generates, well, we need to add our exception clause. So exception, parentheses, nope, sorry, that's kind of more Python. Catch, parentheses, and we found two errors. We found that the parseInt can generate a number format exception. So that's what I'm going to type down here. That's what I want to catch in my catch statement. Catch number format exception with a capital N, a capital F, and a capital E. And we have to give it a variable name. Why not just EX? And this is its own block of code. And this block of code gets executed if inside the try block the code encounters a number format exception. So a number format exception means that they entered something that was a non-integer. Then we're going to print out an error message. System.out.println, that wasn't a whole number. Or bad input, We could say both things. System.out.println, bad input. That wasn't a whole number. We haven't handled the divide by zero error, but we have handled the exception that this one can generate. Well, let's prove that. We're going to run it again. Twice. Or 3 times or 4 times. We're going to run it. We're going to type in bad data, make sure it catches that, and then we're going to try 0 again. Now 0 is going to behave the same way that it did before. So I'm going to run it, bring out my output window, please enter a whole number, 1.1. Bad input, that wasn't a whole number. yeah, the program could handle that still more gracefully, right? It could loop, you know, or something like that rather than just, okay, we're all done. But we have at least stopped it from crashing. Users don't like crashes. So let's fix the other one. Oh, well, let's confirm that the other one is still not fixed, even though it's in a try block. It's not like try magically fixes everything. You have to add the catch to catch the problem. So I'm going to run it again. I'm going to enter a valid number, but it's 0. And it blows up, just as we expected. It generates an arithmetic exception. So we're going to add another catch clause for that. And if you haven't gotten this to work, you know, pause the recording. Next, catch arithmetic exception EX. And really, the only kind of error we're going to get there is a divide by 0. But you can print out the exception itself if you want to. Does a user want to see that kind of stuff? But let's do it so that we can see that kind of stuff. System.out.println ex dot get message, like that. Ex dot get message with a capital M, parentheses into parentheses, then another parentheses and a semicolon. Let's see if that looks good enough for our error reporting purposes. And in my opinion, no, you don't just want to print out the exception messages. You want to give them, you know, good error messages, especially if you're writing this for another language, you know. People who speak Mandarin don't want to see English error messages about exceptions, you know, Spanish or whatever. Please enter a whole number, 0. There's our error. There's our error. Not too bad, right? I mean, it's pretty clear, but let's not print out the exception itself and instead print out a good error message. So I'm going to comment that out and say system.out.println, again, bad input, end quote, semicolon, and system.out.println can't divide by 0. And then the user says, why didn't you tell me in the first place not to divide by 0? So then we'd probably go back up to the printf, you know, the print statement up at the very top and say enter a non-zero whole number. But even if you say that, they might type it in. And what are other things that can generate exceptions? Well, we've just seen 2, but every file operation is rife with opportunities for it to fail. You have to add exception handling to file I/O or it won't even compile, which is a difference for you Python users where you didn't have to add exception handling. And you didn't have to for C++ either. You could just run it, you know, and if it didn't open the file, you could look at that in code, you know, if file.bat or whatever. In Java, you have to add exception handling in order to get file I/O to work, in order to open files, write to files, read from files. Similarly, if you're going to do I/O over other classes, like you're going to establish a connection to a server, you know, and read from a server, same kind of stuff. You have to add exception handling. There is a third catch-all form of exception, and it is pretty bad programming to just use this one to handle all cases, but we have to show it anyways. These are all the specialized form of exceptions, but they all inherit from a superclass called exception. So you could just do this. Catch exception, system.out.println unexpected error. And in that case, you probably really should print out the error message so that the programmer has a chance to figure out what's going on. So println ex dot, you know, get message. There is get localized message. Localized, hopefully meaning locale specific. But I don't know how to specify what locale, so I'm just going to ignore that. Dot get message, parentheses, in parentheses, in parentheses. Okay, now we can't test that because I don't know of how to generate an exception in this stuff that would cause that problem. The only way I can figure out how to do that would be to comment all of this stuff out. I guess I'll do that.
As a letter instead of a number.
It'll still be a bad input if we enter a letter rather than a... The suggestion was, let's type in something completely wrong, like a letter rather than a floating point number. Well, let's give that a shot.
No.
Please enter a whole number. No way. All right, it says bad input. That wasn't a whole number. So what I want is for this stuff to not happen. And the way I'm going to do that is I'm going to cut this one, the catch exception EX, and move it to the top. It's going to be the first catch rather than the last catch. That's actually going to give us errors. Why? Because if you catch the most generic one, there's no way that it's going to be able to catch that one or that one. So you just give up and you comment these other ones out just to prove that this works.
I found a way that it's, I guess, a quick way. If you cast your result as a double and then do it, it'll print out, like, it'll catch it. The exception at the bottom will catch it and then print out what the error was. Like, if that's what you were trying to do without getting rid of the rest of it, it would whatever error it caught that wasn't those other two, it would show.
I'm not getting it yet. Just a sec. Let me come look. Okay, guys, we found a way of actually generating an exception that the other ones don't catch. Just hit undo until that exception block is down where it ought to be, right? Okay, so I'm back to where I was. I have a try. I have a catch number format exception. I have a catch arithmetic exception. Now change the format. Scroll back up and change R from being a int to a double. Clean and build. Not a syntax error, but it's not going to work. Why isn't it going to work? Because our printf statement, we formatted it with %d. R is now a float. So this %d ought to actually be a %f. I'm not going to change it because I don't want to fix it. I want you to see how it worked. So I run it. Please enter a whole number. I'm going to type everything right. 10. And it blows up because it didn't catch it. What have I done wrong? Don't I have my...
You have your get message?
Oh, I forgot to put my last one in when I was undoing things. Okay, fine. Type it in again. Catch exception EX system.out.println unexpected error semicolon system.out.println ex.get lowercase g message uppercase M parentheses in parentheses one more parentheses semicolon. Pause if you need time to type that in. What I did is I just accidentally wound up having removed the third exception handler, the third catch. So if you get back to where I am, you had one catch for number format, you have a second catch for arithmetic, you have a third one for exception. Now when we run it and we type in something, please enter a whole number, it's going to blow up. This isn't real good stuff. The user is not really going to be happy with seeing unexpected error d% equals java.lang.double. But what that was is it was a number format exception. Number format exception meaning that when we try to print f, this is a double, and this %d means it's an int. So we're going to just correct that, right? So 100 divided by d, %d is %f. So now we run it. Let's test it to make sure it works. Please enter a whole number 3. And 100 divided by 3 is 33.00000. And yes, we could have avoided some other problems by making I a double and doing double.parse double. Yeah. Still, the parsing could fail. But if we allowed I to be a double, we would get into a different circumstance. 100 divided by a double value 0 is not an exception. It's just a different looking value. We could do that. Let's not. Okay, so hopefully you see how that works. You may think to yourself, okay, if that one can catch everything, I'm just going to use that one all the time. That's an extraordinarily bad idea, because you need to know what kind of error you're getting. You want to know if it's a file error or if it's a divide by 0 error or a format error or whatever. And if you just catch absolutely everything with one command like that, you can't really differentiate them. Yeah, you might be able to query EX and figure out what kind of exception it is. But it's just considered really, really, really violently bad programming to use catch exception EX as your generic handler without putting others, the ones you're expecting, first. Generally, you want your code to fail if there's a problem, certainly during testing. You don't want that failure to be hidden, to be masked by an overly generous exception handler. All right, that's about enough to talk about exceptions. That gives the idea real clearly, in my opinion, but we're going to go ahead and hit the PowerPoint, see whatever extra illumination we need. So the general format, try, you put a block of code in there. Oh, that's right. I wanted to talk about looping in order to get them to enter good data, right? We're going to modify our code, or we're going to rewrite it so that it does looping to force them to enter good data. Let's do it again. System.out.println, enter a number. And we are going to use doubles this time. Double D. We don't need to actually assign it. Let's not assign it. If you scroll up here, we saw that we had warning messages for use, unassigned values never used. We could get rid of those by, deleting our initialized values. I'm going to expect that that's the case here and just leave that alone. Don't know if that's a good expectation or not. So, system.out.println enter number. I'm going to move that below the variable declaration. And then I'm going to read in our string. S is equal to sc.next. Again. Then I'm going to convert it. D is equal to double, capital D, dot parse, lowercase p, double, capital D. Pass in our string variable. Then let's do double result is equal to 100 divided by D, and let's print it out. System.out.println printf 100 divided by %d equals %d, because now we have two doubles that we're dealing with. \n, end quote. %f, thank you. I always think %d is a double, and it's not. %f is equal to %f, right? Because a double is a floating point type, and d stands for decimal integer or something like that. Okay, so %f is equal to %f \n, end quote, comma, and I need to pass in my two variables, d, comma, and the result, end parentheses, semicolon. Let's run it and make sure it works, and then we'll run it and break it. So I run it. Please enter whole number 1. That works. Please enter a number 2.2. 100 divided by 2.2 is 45. 0.454545. Okay, great. So it works. But if we enter bad data, either in the format of a string, actually that's going to be what will crash it, right? Because we're using a double now, so typing in something with a decimal point is not going to break it. But you can break, doubles pretty easily. Like you could type 1.1.1, and you can't convert that to a double either, just like you couldn't convert a word. So we're going to loop until we get a good value. Trying to think of the most elegant way, the least jinky way of doing it. How about Boolean OK is equal to false? Yeah, I should, I could move that variable declaration up here, but I'm just going to put it there. Yeah, I am going to move it up. Cut that Boolean OK is equal to false. Just stick it under our other variable declaration. And now, while not OK, opening brace, and tab these 3 lines over. System.println. I'm going to delete a couple blank lines. System.out.println needed to be tabbed. S is equal to sc.next needed to be tabbed. And D is equal to double.parseDouble needs to be tabbed. If we get to this point without getting an exception, then OK, we're going to set to true. But we actually haven't added our try-catch yet. So here we go. Let's put a try right here. Try this stuff, and we need to tab in those 3 lines again. And I'm going to add an end while comment to my loop down here, into my loop, just so we can track. The error message we're getting is that we don't have a catch, a try without a catch. So let's catch our error. If we type in bad data, we get a number format exception. So catch, parentheses, number format exception, EX, just like we did on the other one. And let's tell them system.out.println, that's not a number, end quote, in parentheses, semicolon, system.out.println, quote, try again, exclamation mark, end quote, in parentheses, semicolon. Now this is still going to loop forever because we never changed OK equal to true. So I'm going to scroll up here and do OK is equal to true. And this is never going to be reached unless the parse double succeeds. If parse double fails, it's immediately going to jump down here, run the exception, print out our message, go to the bottom of the loop and repeat. So this code's going to loop over and over and over until they finally give in and type good data.
Could you also do it while true or while false and then do a break?
Exactly. That's actually how, the question is, could we have done, while true? And yes, absolutely we could have. If we wanted to do a while true with a break, we would replace that while not OK with a while true. And we would replace that line, that OK is equal to true, with a break. Totally good way of doing it. That's actually my favorite way of doing it, rather than declare an extra variable.
Don't they say it's just good?
Pardon me?
Isn't it like good computer sciencey stuff to use variables instead of just doing while true? And
is it good computer science to use variables rather than? It's certainly easier to flowchart, and if you litter your code with breaks, it becomes hard to follow. But if your loop is small enough to fit on a single page like that, I don't consider it bad. If it becomes longer than a single page, then yeah. All right, so we have a good piece of data now. But I think I'm going to undo that change. I'm still going to make it while not OK on the top of my while loop. And I'm going to go back and change that break again to OK is equal to true. And the reason I'm going to do that is down here where we actually do our division, I'm going to put in some code that says if OK. That's not strictly necessary because by the time we get down here, this would absolutely have to be good. Now we're seeing a problem here. D. It's underlining D. And the reason why is because we did not initialize D. And the compiler is not smart enough to recognize that the only way we could get to this point is if D is a good value, right? The compiler is not going to analyze our code that clearly. So I'm going to go ahead and initialize this with whatever value I want. I just set it equal to 0. Double D is equal to 0. That'll get rid of this error down here. But what if I don't want to risk using the initial value? What if there was some other way out of the loop, besides typing in good data? Like what if they wanted to type in the word stop, something like that. So if, whoopsie, not in the right place. In front of that double result is equal to whatever, I'm going to do if OK, then I'm going to tab those two things over. Double result is equal to 100 divided by D. System.out.printf is equal to 100 divided by %f equals %f. D result. Did I have to do that? I don't think so. No, absolutely not, because there's no way we could get through this loop without OK being true.
So do you have your D set to a value at the top?
I did. I initialized D up at the top because otherwise it's going to continue to highlight that as being an error. The compiler is not smart enough to know that the only way we can get out of this loop is with D set. So it's claiming that D might not have been initialized. So I'm going to go back and put that there. This kind of thing as to whether you close your code, the resulting code, in this kind of thing, if OK, you certainly wouldn't do that if you were using a break statement, right? Did we need it here? No. If you think that makes the logic more complicated, you can remove it. It'll leave it.
So couldn't we have put what you have right there under the OK equals true?
Yeah, could we have embedded this in the try code, just like we did in the other place? Could I take this stuff and move it here? And don't do this because I'm going to undo it immediately. Yeah, we could. But what if we just wanted to write a generic input method that would always do all this stuff? Then you wouldn't want to put the actual meat reason there. So let's do that next. I'm going to get rid of this if OK before we do that, though. I've given myself second thoughts about it. So I'm removing that if OK. I haven't even tested all this yet, and here I am already making changes. I'm going to build it and test it. So the first one wants a whole number. I'm going to type in a whole number. Enter a number. This one doesn't specify a whole number, but I'm going to type in garbage. Try again. That's not a number. Enter a whole number. OK. 100 divided by 10.0 is 10.0. OK, so that works. Do we want to put all of this code? Before we could just call D is equal to sc.next double and be done with it, and we have effectively replaced 1 or 2 lines of code with, I don't know how many this is, 60 down to 76. That's 16 lines of code, including braces. Do we want to have to put that in every single time we want a number? Probably not. So you probably want to make that a method instead. Now here's what I'm going to do. I'm going to take all of this code and put it into a method. Let's go create the method first. I'm going to go down to the end of main. I'm deleting stuff. I'm going to put a comment here saying that this is the end of main. And then static, it's going to return a double. Static double, or get safe double, or next safe double, like that. This means that we're going to have a scanner. So okay, fine, I'm going to pass in a scanner, and I'm going to pass in a message. We could just declare another scanner right then and there, or we could make scanner, a class member so that all of our methods could do it. The message is what we're going to print out, because we may want to print out something more specific than just enter a number, like enter your age or enter your weight or something like that. All right, that's enough. Static double, safe next double, parentheses, scanner SC, comma, string message. Now I'm going to go and grab all this code and cut it and paste it there. So everything inside the loop, and maybe a couple lines even above it. Yeah, like that Boolean OK. Even at double D. Everything, all the way down from double D is equal to 0, Boolean OK is equal to false, all the way to the bottom of the while loop. Cut that, paste it into your next safe double code. And since I have an opening brace here, I'm going to go down to the closing brace and put a comment. End of next safe double. Now the code's not going to compile yet because I've declared this is double, but it's not returning anything. Here you could just put a return statement right here, right? If we get to that point, we know it's good. But instead, I'm going to do it at the bottom. That's better. That's more computer science-y correct. Why am I doing return true? I don't know. Return D, because that's where we stored our resulting value in. It's complaining that it doesn't know what S is, so I'm just going to declare it right there. Why not? String S. I just had to add that line to it. Maybe I'm going to undo that and declare S up at the top. Yeah, I'm going to do that. I took out the word string from there. I'm going to go up here and add it in with the rest of my declarations. String S. So now at the top of next safe double, I have 3 declarations. Double D is equal to 0. Boolean OK is equal to false, and string S. Then I have my while loop with my try. Go ahead and pause if you need a second. Guess your code. Eyeball it. And then we have our catch. Catch number format exception with a print line for an error message. Then we have end while, return D, and then the end of the method. Now we can use this method. Scroll back up. And right before double result is equal to 100 divided by D, just double D is equal to next safe double. Let's pass in our scanner, SC, and let's pass in a message. Please enter whatever, your weight. I don't care. Please enter a number. I forgot to change my print statement down at the bottom to use that message. See, we declared the message here, but we didn't actually use it. So that's what I'm going to have to do next. I'm going to go back to my next safe double method, and for that print statement right there, enter a number, I'm going to replace that with message. So while not OK, try system.out.println message. All right, I'm going to run it, make sure it works, and then I'm going to scroll up and down to give you all a chance to make sure that you've typed it in correctly. So please enter a whole number. Yeah, okay. Please enter a number. I'm going to type in some garbage. That's not a number. Try again. Please enter a number. I'm going to give it a good value. And check it out, 100 divided by 0 is equal to infinity. The floating points type have a special value that they can contain, called infinity. And if you divide by 0 but it's floating point division rather than integer division, that's what it puts there. I don't think you can do math with infinity. I don't think you can do, you know, x is equal to 3 times infinity. I'd be kind of curious to see what that does. But anyways, all right. So here is our new code. Ignoring all that stuff about integer up from above. Here's our 3 lines of code for calling the next safe double, passing in the scanner and the string, with a semicolon at the end, of course. And then double result is equal to 100 divided by d, what we just read in. And then system.out.printf, and then our formatted print statement, 100 divided by %f is equal to %f, \n, comma, d, comma, result. And then the safe double method. Trying to look to see if I did put all the opening braces on the same line, if I could get it to fit. But anyways, you can pause it and eyeball it. And then after the try, we have a catch. After our closing brace for the loop, we return that value. This is one that I'd be awfully tempted to have written if I was coding it for my own purposes. To not do while not okay, I just would have done while true. And instead of setting a flag, I would have returned D from there. But
okay, so I've got mine is blowing up when I put in a whole number.
all right, let me go look. All right, so I think we're good there. Take a little bit, one more peek. The semantics for previous slides try and catch code. Skip that. Number format exception is well named. It's thrown when a number's format is inappropriate. Throw is what they call it when the exception is so-called generated. You can throw your own exceptions if you want. This will be about the last thing we do. But let's go down here and add another method underneath next safe double. And let's just do void test exception, whatever, just test, void test system.out.println. We are about to throw an exception. End quote, comma. Now let's make a number format exception error. Number format exception EX equals new. No, it's a lot of typing. Number format exception, parentheses, and the message inside of it's going to be oopsie. Into parentheses, in semicolon. I'm going to put part of this on the second line to make it easier to spot. Now, throw EX. For this to actually work, it's going to need to be static. I forgot that. So static void test. And I was expecting to see a warning or an error message about the fact, well, here's what you can do. No, I'm not going to even say why I was expecting something to be there. But go up to another part of our code, anywhere really, anywhere that's part of main. So before the end of main, call the test function. And then after it, system.out.printf or println, all done. That's the end of main, right? But this is going to blow up because it's thrown an exception. The test function throws an exception. Invariably, there's no way to get it not to. And so we run it. Yeah, enter whole number 1, enter number 1. And it blows up. It says exception, or we are about to throw an exception, and then sure enough it did. That exception got passed back to main. To handle it, we would have to put it in a try-catch block. But notice we did not have to add exception handling. We could tell the compiler that we absolutely have to handle the exception, that the code won't even work if there's no try-catch block for it. The way you do that is you go down here and you put the word throws on static void test. So static void test throws space a number format exception. That tells the compiler that you have to catch that. And it's still not telling me that you have to catch it. Okay, so.
So what would be the point of putting that there?
There are two different kinds of exceptions. The question is, why would you bother doing that? There are two different kinds of exceptions. There are exceptions that you must handle, and there are exceptions that you don't have to handle. And number format exceptions are something that you don't have to handle, a broad class of exceptions. So, but you could put throws and then put in one of those exceptions that have to be handled, and it would tell the code up there not to even compile. But so far we haven't hit any exceptions that you have to handle. So other than finding the slide that talks about it, checked and unchecked. Okay. So there are two kinds of exceptions, checked and unchecked. Now checked and unchecked don't refer to what you do. They refer to whether the compiler, whether your code has to handle it or not. Unchecked exceptions you don't have to handle. It's good if you do. And that's divide by 0 and number format and all sorts of other kind. But if it's a checked exception, your code has to be inside a try-catch or it won't even compile. So, if your code, if the exception derives, if its parent class is runtime exception or error, then it's an unchecked exception. But every other kind of exception is a checked exception. And so that will make more, that'll be of more import on the next layer, on the next lecture. But for now, let's just leave it as saying that when you define a method, you can tell the program what kind of exception it is going to throw. And this can be very valuable information. The compiler can use it to sometimes force you to handle the exception. Number format exception is an unchecked exception, so even though we have that word there, it's not forced. We could change this to another exception that has to be handled. We're going to try changing that exception to a checked exception. IO exception is a checked exception, for example, according to this slide. So I'm going to go back to my code and test, instead of generating a number format exception, it's going to be IO, all caps, I capital O, E capital E, exception, EX, is equal to new IO exception, EX. Is that too generic? Is it not going to let me generate that one? Fine. Uno momento.
We don't have IO.
So it's not part of java.lang. So java.io.io exception is ex is equal to new java.io exception. And the only reason we're doing this is to show you that there are checked exceptions that you have to handle. Now that's caused an error. If we look at this, it says unreported exception must be caught or declared to be thrown. Well, we're not going to catch it right here. We're going to throw it. So we're going to change that line on the method header, static void test throws java.io exception. Now, do you always have to type java.io? No, we probably would have imported a class that used java.io and brought it in. Okay, so this method now compiles, but where we call it's got an error.
Did you unpause? Sorry.
Yes, I did. Let me make sure. Yes, it's unpaused. Okay, so there's our final version of our test. It generates a checked exception. Since Java.io exception is a checked exception, we either had to catch it right then and there in here, or we had to pass it back. And to pass it back, we had to add a throws clause. So throws Java.io exception. Now scroll back up. Look, I have a red error here. In my main method, where I call test, it's complaining. Unreported exception must be caught or be declared to be thrown. And yeah, you could scroll up to main and put your that it throws it. But instead, you're going to want to try it. Try test in block catch java.io exception. Just print oopsie. System.out.println. Oh, I forgot to give it a variable name. Catch java.io exception ex system.out.println io exception caught. Keep watching it. Java.io .io exception ex system.out.println io exception caught. Semicolon. And now when we run it, it'll work. What did this prove? This proved that there are things called checked exceptions. Checked exceptions have to be caught by the code or else it won't even compile. It did not compile until I put this function inside a try block and with a catch for that function, for that exception. And that your code can throw your own exceptions if you want to use exception handling as your method for handling errors. Or if the method itself is using something that can generate an exception, you can instead throw that exception back up a layer to whatever method called this method instead of handling it right then and there, which is sometimes not a bad idea. Maybe you want your main loop to catch the exception rather than each method that the main loop calls. All right, that makes sense?
That's really cool. I really kind of wish I knew about that earlier.
Cool. Alrighty. So go ahead and upload this to the Dropbox. And next we will talk about file I/O and using exception handling there, because using exception handling for file I/O is an absolute must, because the file I/O exceptions are all checked exceptions, so you can't even implement the code without it.